Okay, so today we will learn about the inverse circular function, their graphing, and we will learn also about the graphing of the reciprocal circular function. So first, inverse circular function. So if we have y equals sine x, and we sketch the graph of the sine x, we have 2 pi, we have pi. Now, and we want to sketch the graph, and we need to establish the function y equals sine negative 1x, or international notation. Be prepared that you will be getting that. Often it's arc sine. This is international notation. Sine negative 1 is not international notation. It's arc sine. So, if we will want to sketch the graph, what problem we will have here?
There's no problem.
There is a problem. What is the condition of the function to have inverse?
Can't be a one-to-one function.
It must be one-to-one function.
No,
This is not.
You're
Function is not one.
You can always have an inverse, just not an inverse function.
Oh my god, it has to be one-to-one.
To have inverse function, original must be one-to-one. So how we can make this function one-to-one?
Chop it off in the middle and maximum. Like
We need to choose domain.
yeah.
We need to choose domain where sine will be one-to-one function. And we have it from here to here. If we choose this, if we will limit domain of sine from negative pi on 2 to pi on 2, sine becomes one-to-one function. So pi on 2 is here, pi on 2 is here. And then we can sketch the graph of the inverse function and define its domain and range. So what is the relationship between domains and range of the function and inverse function?
Opposite.
So if we have f of x, we have, it has some domain, have some range. And we have f negative 1x,
Domain.
they are its domain equal range of the original and range equal domain of the original, they swap. So, y equals sine negative 1x, what will be the domain of the function of the f of x? F of x equal sine negative 1x. So, its domain
Negative one-to-one.
will be range of this. So, we have domain is negative 1 to 1, and what will be its range?
Negative pi on 2 to pi.
From negative pi on 2 to pi on 2. And let's sketch the graph. What the relationship between the graph of the function and its inverse?
Reflection in the y equals xx.
Reflection in the line y equals x. Reflection in the line y equals x. So we will have the graph of the y equals sine negative 1x is equal negative 1, 1, we have pi on 2, negative pi on 2, and that will be something like this. This is how the graph of the sine negative 1x looks like. And here's original, its starting point and end point. Now let's see some transformations that can happen with it. And let's say if we need to sketch the graph of y equal 2 sine negative 1 of x minus pi on 2. Sorry, not minus pi on 2, x minus 1/2. And we will do, sorry, again, let's do 2x.
What?
2x minus 1. Okay. Y equal 2 sine negative 1, 2x minus 1.
Domain?
First, we need to look, yes, how this transformation, what transformations we have here.
Dilation of 2 from
What
x.
is this?
Dilation of 2 from x.
Dilation 2 from x-axis. What we have here? What we need to do here before we
Dilation of
do,
half from y.
we need to take
Brackets.
2 as a common factor. We need to rewrite it as 2 times x minus 1/2. Why we need to do that?
Because then you can see the translation.
You don't,
Then we can
you
see.
don't need to do that.
Okay, Joseph.
To avoid silly mistake and see the proper horizontal translation, you need to do that. To see that it's translation of 1/2 to the right.
Right.
So, what will be now domain of this? It was minus 1, 1. Was minus 1, 1. When we have now 2x, what happens with the domain? What this will do with the domain? It's half it. It's half it because this is dilation from y by factor 1/2. So we have domain now will be only looking for this will be from negative half to 1/2. That, by the way, you can pretty easily have such question in the 3-4 final exam, like this. So domain negative half to half. But that's I take only this. Now what this will do with the
0 to
domain?
1 plus.
This move half to the right, so it will become from 0 to 1. So this is the domain. And what will be the range?
Negative pi.
Just times and 2, it becomes negative pi to pi. So the graph will be, starting point is negative, starting point is 0,
But we're moving it 1 right. Or half
starting
right.
point 0, but y value is negative pi. Now, that's all after we move. This is the final domain. What will be the x-intercept?
Half. That's what I was talking
It
about.
will be 1/2, and final will be pi. So that is negative pi. This is pi, and so that will be at 1/2 y-intercept. So that's how it will look like with the points minus 0 minus pi, and this point is 1 pi. Make sense how we sketch this graph? Now, let's see inverse cos. What will be the inverse cos graph? Again, we need to choose to sketch the inverse cos graph. We need to identify where cos is 1-to-1 function, whereas cos is 1-to-1 function. And so we're starting from y equal cos x, and we can choose different parts because it's periodic functions repeat itself. So, but we can tell from here to pi, where it's 1 and negative 1, and if we cut cos like that, we limit domain of cos from 0 to pi, we will have, it becomes 1-to-1. So for cos negative 1, if we have y equal cos negative 1x, what will be the domain? What will be domain of cos negative 1?
Negative 1 to 1.
Same as if it's sine negative 1 to 1. And what will be the range?
The range will be 0 to pi.
Range will be 0 to pi. And if you sketch the graph, it starts from it starts from when we have domain negative 1 to 1. We have negative 1 to 1, and we have that is range is 0 to pi, 0 to pi. When it's pi, it's here, pi on 2, and that's how it will look like. That is graph of the cos negative 1x.
Wait, why isn't it going below the y-axis? Oh, because of domain. Yeah.
Because this is not going to the left of the x. Makes sense how I obtained the graph of cos negative 1x?
Yep.
Now, 10. 10 negative 1, so we start from y equal 10x.
I don't like a 10 graph.
And 10 is 1 to 1 already. If you look from minus pi on 2 to pi on 2,
How do you know what's with the asymptotes on a 10 graph?
asymptote on the 10 graph?
How do you know? What?
Because what is 10? Sine over cos. When cos
No,
equals
but
0,
wait, how do you know where to put the asymptotes?
where cos equals 0. Because you cannot divide by 0. And cos equals 0 at negative pi on 2, then 3 pi on 2, and further.
So, no matter what, it will be on the same asymptotes.
No, if you have for example, if you have dilation from y, asymptotes can go wider, further away, or closer together, or it will be horizontal transfer. They can change. But for 10x, it's just minus pi into pi and 2 and so on. And this is the 10 graph. And 10 negative 1. 10 negative 1 will be. What will be the domain? What will be the domain of 10 negative 1? What is the domain of 10 negative 1? All real numbers. Domain, all real numbers. And what will be the range? From negative pi on 2 to pi on 2.
So how does that?
And this time including or not including?
Included. Not included.
This is the asymptote. So it's not included. From minus pi on 2 to pi on 2. And graph looks like this. We have now horizontal. If graph of the original function has vertical asymptotes, graph of the inverse has horizontal asymptotes. We have pi on 2, negative pi on 2, and that will be the graph of the 10 inverse.
It looks like a cubic and then this is
Okay, as a cubic root.
yeah.
Yeah, they're similar, 10 similar, not exactly, but they are quite similar to cubic x, and 10 negative 1 to cubic root of x. Now, often, it's relatively often in the equations, you need to find inverse of the function or function of the inverse. If it's the same function, it will be pretty easy. If you will need to find what will be sine negative 1 of sine x.
Is that common to functions? Is it one?
No, it will have a function of the inverse function, inverse function of the function. What will be always the result? X. It will be x. And so sine,
It is composite function.
There's a domain though.
it's a negative 1x will be equals x. Of course it will have limitations.
Yep.
I'm talking about the formula. And same will be cos of cos negative 1 or cos negative 1 of cos x and will be x, so will be 10, 10 negative 1. But what will be and how we can find, if you need find, for example, let's say if you need to find, let's say you want to find cos of sine negative 1. Cos of sine negative 1x. How we can do that?
Can we switch cos like we
Let's sketch the easiest way. Sketch small rectangle triangle. And let's say this is angle theta. The sine is an angle. Sine negative 1 is an angle. Yeah? Sine negative 1 is an angle. So if we have hypotenuse 1 and the opposite is x, then what sine theta equal? Then theta, what's theta? Angle theta, we have sine theta equals x. So x. What will be this side equal?
1 minus x squared.
Square root, we have square root of 1 minus x squared.
Why would you need 1x in that? Like, why did you choose that?
So what will be equal cos theta? What cos theta equal?
X on
Square root of 1 minus x squared.
Yeah, on 1. Yeah.
On 1. So let's say sine negative 1 of x equals theta. Then what cos theta equal? Square root of 1 minus x squared.
I don't get it.
If we have such triangle,
Yeah.
what is, and we look in, probably should be,
How do you even know what sine inverse is?
You're right. What's that?
We have,
Is that an inverse?
we're looking for cos of angle theta, right? This, let's say this angle theta. What is sine of theta?
X.
X. What is then x equal?
Oh shit.
If sine theta equals x, then x equals sine negative 1 theta.
Why?
Oh, bro.
How you find, if you have sine theta equal 1/2. What theta equal?
Pi on 6.
How you know?
I like
So we take theta equals sine negative 1 of 1/2. It's the same with all inverse function. For example, exponential and logs. Exponential and log. If you have 2 in the power of 2 in the power of x equals 8. Then what x equals?
3. Wait, what shouldn't it be?
No, how we rearrange it?
Sine.
I think you may have
Shouldn't it be
done it
sine inverse
Huh?
of x equals theta?
wrong. Sine inverse of x equals theta. No.
Oh, sorry.
Yes.
Yeah.
Joyce is like x right.
Yeah. Theta, the angle equals sine negative 1 of x. Yes. Yes. Yeah.
Sine of x, bro. What's the inverse of y equals to x?
Bro.
Yeah.
Are you
No.
Bro.
I made a stupid mistake.
So
Yes.
stupid.
So yeah. Now that makes sense.
Bro.
Yeah.
That's enough. So that's how we find
Oh.
this. If we say as sine theta in this triangle equal x, then theta equals sine negative 1x. And so we have cos of this angle equal square root of 1 minus x squared. What will be from here, using the same triangle, what will be equal for example, 10 of sine negative 1x. What will be 10 of sine negative 1x?
It was the x on root 1 minus x squared.
Will be x over square root of 1 minus x squared.
Do we always need to remember that sine inverse of x equals theta? Is it a thing that's always?
The triangle, this will draw different triangles for different
So
situations.
it's still the same thing, like it's still adjacent of the hypotenuse.
Yes.
So-
Opposite,
so-
opposite over adjacent. 10 is opposite over adjacent. And this
Is
is
that always like that? Like,
10 always opposite over adjacent.
no, I mean like when it's sine inverse of it.
Okay, if you want to find, for example, let's say you want to find, sine of a 10 negative 1. Sine of a 10 negative 1x. In this case, we draw the right angle triangle. We draw right angle triangle. Let's say this is angle theta. So what we can write about this angle? We want this, that 10, it's not very right angle triangle, what is, if this is theta,
So that would be x.
and let's say the opposite side is x,
And that's
what will be equal 10 theta? 10, and this is 1.
x on 1, x.
10, we want 10 theta equals x. That's why we position, you see, I positions x and 1 differently, because I want to have now theta equal 10 negative 1x. What will the hypotenuse equal? What hypotenuse will be
X squared
equal?
plus 1 under the square root.
Square root of 1 plus x squared. And what will the sine equal of this angle?
X on 1 minus x squared.
Equal x over square root 1 plus x squared. So you always do triangle in the way.
That's in the bracket.
If you have inside you have sine negative 1x, you will need to have x opposite 1 hypotenuse.
You want sine to be equal x. That's
Yes. Here we have 10 negative 1x. We want 10 equals x. So we take opposite x and adjacent 1. Tell me how we need to draw the triangle if I want to find, for example, 10 of cos negative 1x.
it. Okay, so draw the triangle. So you will have x will be the
Because we're talking about the cos.
this side, will be x.
And what hypotenuse will be?
1.
And hypotenuse is 1. Does everyone understand why I choose x there and 1 there?
What if you have what
Because I want to have what is inside. Here will be equal just x. So, and then this side will be equal square root of 1 minus x
what if you
squared.
have cos x in the bracket?
So you want
Just cos x, not arc cos x.
Hmm?
What
If you have 10 of cos, you
Yeah.
cannot do anything.
Okay.
You cannot simplify that.
Okay.
Yes, it was a question. So,
Yeah,
yes.
but like, would we get like 10 cos inverse of like 2 or something like that?
Cos inverse of negative
Would
2
x
doesn't
have
exist.
value?
So, does cos inverse of 2 can exist? Can cos be equal to?
Okay, well not 2, but would you get like
Why not?
a value for
Right.
it? Like, would it always be, would you always have like 1 and x in your triangle, or would there be other,
No, it will be 1 and x
all the time?
all the time. That you just need to position, where position x, and you might have either root 1 minus x squared, or if you have x1 here, this will be root of 1 plus x. Make sense?
Yeah.
How
Let's
to
say
deal?
if it's cos inverse, then you want to make like the cos equals to x, right?
Yes.
If it's tan inverse, then you make the tan equals to x.
So what is this
Exactly.
again? If we're
Yes.
taking fine.
Okay, and today we're looking at one more thing. So we're looking into the graphing of the inverse circular function. Now graphing of the reciprocal circular functions. Graphing of the reciprocal circular function. And this is the principle how we draw in general the reciprocal graphs. So to sketch the graph of y equal, once y equal cosecant x. How you sketch graph y equal cosecant x? What is cosecant?
1 on sine x.
1 on sine. So
Hyperbola.
let's to sketch a reciprocal graph, you always start from the original graph. We sketch sine x. And now we'll draw two cycles, one to the left, one to the right. So we sketch sine x. And we have 1, we have -1, we have pi, 2 pi, pi over 2. So now when we divide, when sine x equals 0, what will happen when sine x equals 0?
They'll define asymptotes.
We will have asymptote. So we will have where original graph has x-intercepts, the reciprocal graph will have asymptotes.
They'll be asymptotes.
So we have
1
asymptotes.
on sine.
Now,
Sine x equals 0, 1 0 is defined.
because we cannot have 0 here, so where it was sine x equals 0, then for 1 on sine x will be vertical asymptote. Now, this graph has maximum. Let's look into only this bit.
Yeah.
It has maximum. But we're doing 1 over. So where the original function has maximum, what will be reciprocal function? Has a minimum.
Well, 1. I just said it because I just said that.
Because when we dividing by this value, when we dividing by the biggest number,
Yeah.
we'll get the smallest number. So when it was maximum of the original, reciprocal, because we dividing by the biggest that the original can be, we'll get the smallest reciprocal.
Right.
So where it was does it make sense? Because that will be very important, by the way, on your SAC. You will be doing, I can tell you, you will have to investigate some functions, some
Investigate?
reciprocal functions.
Why investigate?
Sit up. What?
Is it investigation?
Talk about sack.
Yes.
Yeah, but
called
we're
investigation.
investigating functions, we're not circles.
Yep.
It's an investigation set.
Yes.
What?
For the special.
Let's talk about SAC a little bit later on. And a little bit, I will tell you something about your method SAC as well, later. So, we have and what is value of the sine at maximum? What is equal?
1.
1.
So it's
So
1.
what will be minimum of the reciprocal? 1. And when we have here, when sine approaching 0, what 1 on sine will be approaching?
Infinity.
Infinity. Positive infinity, so that will be the touching of this point.
Yeah.
Now,
6.
here,
Same thing.
we'll
but
have same thing, but it's approaching negative infinity.
Let's see.
And here, again, will be approaching negative infinity, so that will be periodic function as well, the reciprocal sine graph.
That's sick.
Make sense?
Yeah.
Okay, that's pretty much what I wanted to explain you today. Theory, like, subscribe and donate to help fight terrorist countries like Russia and organizations like Hamas. Support Ukraine and Israel.
Amen.